Polar coordinates and polar graphs. Essentially, well, this section, I think I'm splitting it into two, and we're just going to do all the non-calculus stuff here. Just so polar coordinates, polar graphs, right? And the part about polar coordinates that just unnerves me, I'm pretty sure I told you in pre-calc. Does anybody remember what the two coordinates are for the polar graphing system? There's a radius and there's an
anti-radius. Oh, that's probably close. First it is. What does that even mean?
Well, let's look at the polar axis, the polar.
Beta.
Did you say beta?
I said beta.
Did you mean?
Delta.
Yeah, we got a theta. Theta stands for an angle. We have a theta and a radius. However, in the rectangular system, x comes first, correct?
Yep.
And x is the independent variable, and y is the dependent variable. But in the polar system, for whatever reason, they put the r first, and then the theta. And r is the dependent variable. It depends on the theta, which is the independent one. Is it ANT or ENT? ANT, isn't it? Dependent. It's ENT? Okay. All right. So when I'm graphing polar coordinates, it's just weird. But I think I finally figured out why whoever decided, like if the angle is 0, if I ask you to graph some of these points, 2, 0, -3, 0, 2 pi over 4, -1 pi over 3. My thought process, just like we usually go x first and then y, right? My thought process is do the angle first and then go out with the radius. And so if I have a 0 angle, right, and then I'm going out 2 units, this is the coordinate for, or the graphed point for 2, 0. And therefore, the reason I think whoever made up the system didn't make it 0, 2, because they were like, well, if I ask you the coordinates of A in rectangular coordinates, what would you say?
Oh, up 2, yeah.
It would be right 2, up 0. That's why I think they did r theta. I think. Because on the 0 line, it looks the same as rectangular. Does that make sense? All right, so how would I go -3, 0, though? Instead of going to the right towards the 0 for the positive radiuses, I'm going to go left for the negative radii, And same thing, the rectangular coordinates for B would also be -3, 0, correct? But how would I graph 2 pi over 4? Well, we're going pi. Again, I know I had a student that always chose to do the r first. To me, it's better to think of the angle first. Pi over 4 is right there, correct? 45 degrees. A +2 means go out 2 units on that angle. Does that make sense?
Oh, I remember this.
Yeah. But if I change that one into rectangular coordinates, what in the world would it be? 2 is the hypotenuse. What would the 2 legs be for a 45, 45, 90? Square root of 2. So that would just be root 2 for rectangular coordinates, wouldn't it? How about -1 pi over 3? Again, think of it. Pi over 3 is the angle. A positive radius would go up into quadrant 1, correct? Which quadrant would a negative radius go to? Quadrant 3, 1 unit. Everybody good for D? So pi over 3 is a 60-degree angle, correct?
Yeah.
A positive R would go up into quadrant 1, but a negative R would just go backwards.
Okay.
Can we turn that into rectangular coordinates? Hypotenuse is 1. What kind of angle is that one here? Pi over 3 is how many degrees? 60. Here's the 30. What's the short leg going to be if the hypotenuse is 1?
1/2.
Half of it, right? And we're going left, so the x value would be -1/2. And what would the y value be then? Long leg is short leg times square root of 3.
Root 3 over 2.
Yep. And it's negative because we're going down, right? There will be, I will ask you to convert sometimes from polar to rectangular. Somebody give me the name of a point on the y-axis up here and down there. What will point E be? Give me one.
That would be like 3, 0. Right?
3, 0 is going to go right 3, right? What angle is that?
Oh,
What angle is that?
90.
Which is pi over 2. I hear a 4. 1, 2, 3, 4. There's E. And what would that in rectangular coordinates be? 0, 4, right? The y value would be 4. Give me one on the y-axis down, going straight down. -4 pi over 2 would send us down there. And that would be 0, -4 rectangular coordinates. Somebody give me one in quadrant 2. -1 pi over 4 would actually head in what quadrant? That would be the third quadrant.
Would it be 1?
How about if I threw a negative pi over 4? Can I make it -2 just to make it a little bit bigger? -2, negative pi over 4, then we'd go backwards right here. Rectangular coordinates. I know the radius, or they're calling it -2, but it still is just a distance of 2, right? And the 2 legs are the, yeah, root 2, but we're going to go negative root 2, positive root 2. I made that one too easy. So give me one. We already actually have D in quadrant 3, don't we? Give me one in quadrant 4.
3 pi, wait, sorry, 2 to 3 pi over.
I'm going to do something other than 2 for the radius.
Okay, -3.
Oh, -3.
3 pi over 4.
3 pi over 4. Everybody following that? 3 pi over 4 is over in quadrant 2, the negative radius. 1, 2, 3. Now, how about that one in rectangular coordinates. The hypotenuse is what? 3. How are we going to get the legs from the hypotenuse in a 45, 45, 90?
Root 3. Root 2.
Divide the hypotenuse by root 2. So 3 root 2 over 2. Positive 3 root 2 over 2. And negative 3 root 2 over 2. Give me the coordinates of this point right here and this point right here. Give me the coordinates of I and J. Give me, actually, you realize there's like an infinite number of ways we could name these in polar, right? Because we could just keep going around. We could call the angle 7 pi over 6 with what radius?
3.
3. 7 pi over 6. But couldn't we say negative 3 and pi over 6? Yeah. And I'm sorry, I jumped I. Sorry. So 3 is the hypotenuse. That y value is half of 3, isn't it? What is the x value going to be?
Negative 3 root 3 over 2.
Multiply that by root 3. What about I?
Negative 4 pi over 3.
Oh, negative 4 pi over 3. Give me one with a positive radius. Positive 4. Give me a negative theta.
4 pi over 3. Oh, negative theta. Oh.
Give me a negative theta.
Negative pi over 3.
Negative pi over 3 is here.
Negative 2. Oh.
Negative 2 pi over 3, right? Or positive what? 4 pi over 3? Is that what you had already said? Yeah. So if we're going to rectangular coordinates on that one, the hypotenuse is 4, the short leg would be 2, and only negative 2, right? And the long leg would be short leg times root 3, and they are both negative because we're going left and down. Feel good about that? That's a lot of pre-calc review in terms of 30, 60, 90, 45, 45. All right, so we move from plotting those points to graphing polar equations. The easy polar equations, R equals 2. In my head, I think it doesn't matter what the angle is, the radius always equals what? 2. So if I'm graphing that, 1, 2, angle changes, the radius stays. It's a perfect what? Circle. Anybody know how we could change that to rectangular? We just did the conics, didn't we? No, even easier. Rectangulars have x's and y's, right?
X squared over 4 plus y squared over 4. Right?
X squared over 4 plus y squared over 4 makes x squared plus y squared equal to what? 4. Yeah, you did it the hard way. But yeah, x squared over 4 plus y squared over 4 equals 1 would be like the ellipse kind of way to think of it, but it does equal 4. In other words, x squared plus y squared equals r squared. Guys, there's some other conversion formulas, like but honestly, we can get them just by drawing out, like, if this is the radius of the point, right? What value in rectangular coordinates is this? X or Y? Y. What value is this? So conversions, if I just look at that as a right triangle, what do we have? X squared plus equals r squared, the Pythagorean theorem. What do we have for sines and cosines? If this is our theta, what is the sine of theta equal to? Y over r. So then y would equal what? R times, this is one of the conversions you'll see. Cosine of theta would equal what? X over r, just the adjacent over hypotenuse. So then x would equal r cosine theta. What would the tangent of theta equal? Y over x. If you ever saw that, you could substitute the tangent of theta. Or if you saw tangent of theta, you can convert it to y over x, right? I'm pretty sure that's kind of all of the little conversion formulas they mention. So if I was just converting, if r equals 2, then certainly x squared plus y squared equals 2 squared, right? Would be a conversion. And we just graphed it. On the same one, so I'm going to draw a little line. This one is r equals 2. Can someone graph a theta equals pi over 6? In my head, I'm thinking the angle is always what? Pi over 6 or 30 degrees, right? So the angle, pi over 6 is right there for all the positive r's. Where do the negative r's go? Quadrant 3. That's just a straight line, isn't it? So how would I convert that one to rectangular without even using a conversion formula? How do you do the equation of a line? Y equals mx plus b. What's the b in this case? What's the m? Rise over run. If I went out to that point, how many, because that hypotenuse is 2, right? How many have we risen? Not, it should be 1. Because 2 is the hypotenuse, that would have to be a 30, because that's a 30, right? This we would rise 1, and we would run how many? Short leg is 1, hypotenuse is 2, long leg is the short leg times square root of 3. Rise 1, run square root of 3. 1 over square root of 3x. Or obviously you can rationalize. Does that make sense? Not a real conversion issue at all. But what if I ask you to graph r equals just the cosine of theta? Oh, let's say 2 cosine theta. Any ideas how we go about that?
You could go 4 cosine theta, wait, cosine squared theta equals x squared plus plus. I don't know.
That was Susanna. What did you say?
I think I'm wrong, never mind.
If all else fails and we're without a calculator, what can we always do? A theta R chart, right? If theta is 0, what's the cosine of 0? Times 2. I mean, a nice one is like pi over 3, isn't it? Because that's a 60-degree angle, and the cosine is 1/2, right? Times 2 would be 1. Pi over 6 is not beautiful because that's the root 3 over 2, isn't it? Times 2 would just be root 3. I think that's about 1.8 something. Isn't it? Square root of 4. No, maybe it's less than 1.8. Maybe 1.7. Square root of 2 is 1.4-ish. So it might be 1. I don't know. Square root of 3. 1.732. Good job. All right. What about negative pi over 6 then? Still the square root of 3? What about when we get all the way to pi over 2?
It's just 0.
It's just 0. So let's take what we have and start plotting some points. 0, 2, negative pi over 6, 1.7-ish. Pi over 6, 1.7-ish. Pi over 3 is 1. Pi over 2 back to 0. This one would be symmetric. Are y'all seeing what I'm seeing? If we did pi over 4, just for fun, cosine of pi over 4 is root 2 over 2, isn't it? Times 2 would be root 2, which I already said was like 1.4. Does 1.4 fit in there? Yep. It is the perfect little circle. Now, do y'all remember the polar mode on your calculators? Grab it. We'll test it. Yeah.
Mode. Obviously, POL.
Next up, so it can't be the gym tomorrow.
After he comes back, grab your, switch your mode to what? POL. We just worked on parametric, right? Going to polar. And when we go to y equals, look what happens. It changes it to R. R equals 2. And by the way, when you hit the X button, look what it automatically changes it to. Theta. Let's look what our window is set. Our window is set calling theta from 0 to 2 pi, right? And negative 10 to positive 10. Let's see what happens. I mean, we don't need that many X's and Y's, do we? Let's see what Zoom Square does. Makes it more circular. Because Zoom Square, you know, it's really a rectangle. So when they do 10 or 5 by 5, so they need to show a few more X's. Now, if y'all remember, is this ringing a bell at all? A little bit.
It's not too hard.
How about if I told you to graph y equals 3 cosine of 2 theta? Don't jump to the calculator.
Don't you have to get y into r?
We actually don't have to convert this at all. We are graphing in the polar form. So we pick some thetas. 0 is a good one, right? I know it's 2 theta, it's not plain theta. So if I wanted to end up with pi over 6, what would I, because I like the sign of that as 1/2, right? Pi over 12 gives me 1/2 for a, oh, that's a cosine, sorry. I was looking for sine. What cosine gives me 1/2? Pi over 3. So what would I choose? Pi over 6 would give me the 1/2, so that'd be 3/2. What's the cosine of 0? Times 3. What is pi over 4 times 2? Cosine of pi over 2, 0. Negative pi over 6 would have a positive cosine still, 3/2. Negative pi over 4 would still have the positive, oh, but it would still be 0. Let's see what these points show us on the graph. One, 2, 3. Pi over 6 is 1.5. Pi over 4 back to 0. Oh, let's keep going. What about pi over 3? What's 2 times pi over 3? 2 pi over 3 ends up in the second quadrant, right? So is that a negative 1/2? Negative 3/2? Does that make sense? So I'm following my curve around, and when I get to pi over 3, I'm actually going to negative. What happens at pi over 2? Times 2 would be pi. Cosine of pi is negative 1. Negative 3. Are y'all seeing what I'm seeing as we form it? It is going to be a 4-leafed or 4-petaled rose. It's really cool. Kind of flying through that, but 3 cosine 2 theta. I had done the cosine of, why didn't I do a sine? What would be the difference in the 3 sine 2 theta? Still 4 leaves, but they're in different quadrants, aren't they? Because the sine of 0 is 0. It would start off 0. And then at pi over 4 times 2 would be the 1, right? Times 3. this one is the sine. So interestingly enough, anytime there's an even number, you double it for the petals. So if I made it 4 theta, we would have 8 leaves or petals. However,
Try 16.
if you make it an odd number, it's only that number. It's just strange how that works.
Can you try 16?
Yeah, I want to see 16.
Okay.
Like 64.
Do 800.
No.
Whoa. 64.
That would just
That'd
be
be
like a
solid
whole
circle.
circle.
I bet it would. Let's see. Let's just go 32.
That might just create solid circle.
No?
Try 120. I think that would.
We want a circle.
It might all just always look the same.
Yeah, I guess so.
All right. Let's see, let's just delete that. I want to go and show you how it is. I'm going to do the dash and so you can actually watch it create it.
That is weird.
And by the way, that window is set for theta to go between 0 and 2 pi. I want you to look carefully. If I do 3 theta, it is tracing around it twice. So what that means is it only takes pi units to actually trace around it one time. As we move through this, you're going to actually have to figure out, like, where does that intersect just r equals 2? You would have to figure out where it hits 2. So there'd be a little bit of calculating, right? How many intersections do we have?
6.
Yeah. As we do areas, though, in polar, even without the intersection, how would you figure out the area of the whole of all those petals?
Figure out the area of 1.
Figure out the area of 1 and multiply by 2. And what's interesting is so how long would it take to go around that one petal? Those are questions you have to ask yourself. Like, if I'm making my little table for this one, because you may have to do it without a calculator at times. R equals 3 sine 3 theta. How long will it take to get around the whole thing? Where's the sine going to be 0? At 0, right? Where is it going to reach the outermost tip? If I think of the sine curve, what's the highest point? When it gets to 1. Now, this thing equals pi over 2, so what would theta be? Pi over 6, right? We're going to do 1/3 to solve for theta. So pi over 6 is where it reaches, where it reaches the outermost or the highest point, 1 times 3. Actually, this might be enough, because if I split that petal into from 0 to pi over 6, what would the area of this half of the petal be compared to the other half? Equal, exactly the same, right? So we can use symmetry all around here. Those are things we can do. Now we have other figures that aren't the roses, like 3 minus cosine of theta. It's not, doesn't look very, it almost looks circular, doesn't it? But if I say 3 minus 2 cosine theta, it has a little dimple. It's called a cardioid. But if I say 3 minus 4 cosine theta, it's actually got a little loop in the middle.
How does that happen? Like, what makes it do that?
Well, let's look at, it's just all literally about figuring out what is happening as theta changes, right? What are some good thetas we like for cosine? 0, pi over 3 is a good one, pi over 2, negative pi over 3, negative pi over 2. Pi is a good one, right? So let's see what is happening to the figure. Cosine of 0 is 1 times 4 would be 4. 3 minus 4 is negative 1. 0 backwards 1. As we move up here to pi over 3, cosine of pi over 3 is a half, isn't it? Times 4 would be 2. 3 minus 2 would be. So what happens is, at some point, it hits through 0, and at pi over 3, we're up to 1. Pi over 2, the cosine, though, is 0, and 3 minus 0 is 3. So this is how it happens. At pi, we're going to have negative 1. That's going to be a positive 7, isn't it? Negative 4 times negative 1. So we're going to have 1, 2, 3, 4. We're going to go way out here on the left. And so when we come back on the right side, we're going to have that little loop again. And it's going to slide way down here to 7. So there's symmetry all the time, and those negative R values is what creates the loop, the inner loop. What happens if we added? Did we already do that one? Still a loop, but it actually goes on the other side. So that the negative values show up over here, don't they? Does that make sense? And the same is true for sines. It's just that it's going to be up on the top, right? Cardioids, we have, they give you like a little, on page 737, we have a limison is where you have like, if I had 9,
Now do it again.
Is that ice spice man? Is that ice spice man?
What's that? Oh.
guys, this one is actually a little dimple. It looks perfectly circular, but it actually has a little dimple right down there. So it's, anyway. So essentially today, graphing, there could be a time I ask you to convert to rectangular form. If I ask you to convert that to rectangular form, this is where we get a little bit tricky. What did I say the cosine of theta is from the graph, or from the point?
The X.
X over R
Yeah, X over R. So
times X over R, right? Multiply both sides by R, what do I get? R squared equals 5x. But from the conversion, what does R squared always equal to? Pythagorean theorem. X squared plus Y squared equals 5x.
what is X squared?
Then we could actually, remember what we did at the beginning? Completed the square. Half of the negative 5 is negative 5 halves.
Squared.
What are we adding? 25 fourths. So this is a circle centered where? At 5 halves 0, with radius 5 halves, right? So if I graph it, 5 cosine theta. Oh, let me zoom square. Does it make sense if the radius, I'm sorry, if the hypotenuse, the diameter is 5, right?
Yeah.
The radius would be what?
5
5 halves. Center is 5 halves 0, right? So I will be asking you to convert some. I'll be asking you to graph a little bit using polar, and no calculus yet. We'll do the calculus next time.